You're welcome to today's lesson. And by the time we've recorded this video, it is an evening time. I'd like to take this opportunity to say that good evening. Our topic today is going to be about the equations of straight lines. Under this, we may first ask ourselves that what could a straight line be? Mainly, a straight line is a one-dimensional figure like this. It's a one-dimensional figure. But this line here, mathematically, we take it to be with various or a series of numbers connected in an infinite row form. Why? Because straight lines there are those that are endless. But then this line is made up of very, very small, tiny points, which are always in a row form, but there are those which are also in vertical form. Therefore, straight lines can be horizontally, can be vertically, and at some point, this can be vertical like this, and at some point, a straight line can be at an angle. Mainly, that's what we can define by a straight line. Then another thing which we are going to look at here, or what you can ask yourself, what could be the types of straight lines? There are very many types of straight lines, but for us, we are going to mainly concentrate at only two, the parallel lines and the perpendicular lines. And you could be asking yourself, what are parallel lines and what are perpendicular lines? Parallel lines are lines which do not meet, and then they are always at the same distance from one another. Then perpendicular lines are lines which are always intersecting, cross, or meet at an angle of 90, like these ones here. If this is a line 1, being line 1, this one here, and then this being line 2, these two lines are meeting at an angle of 90. This symbol here signifies a 90. Then another thing, we've said that parallel lines, for them, they are like this. And then if these two lines are parallel, meaning that they will never meet, but they do have still a same distance apart. Then mathematically, we are to go deep with time to understand what could be the mathematical trick behind them. Those are the things that we are going to look at today. In terms of gradients, how are these related? In terms of gradients, how are these two lines related? Well, in this lesson, I welcome you. Please, once again, subscribe to our channel and then recommend the lesson to other people of your caliber to also learn from us. In this, by the end of this lesson, there are things that we should be knowing and being sure about them by the end of this lesson. Mainly, our learning outcomes are going to be as below. Our first learning outcome is going to be learning the relationship of a linear equation y equals to mx plus c, whereby we are to learn how are these simple terms that we are having in this equation here related to be considered. as the main terms that give rise to our equation of a straight line. Then another thing that we are going to look at, we are to determine the x and y intercepts given the equation of a straight line. Then we are to also determine the gradient of a straight line. Of a straight line. Then another thing, we are to state the gradient of a straight line. We can put that here. We are to determine, and also later on we shall state if when you are given us an equation whereby you will not need to then calculate for the gradient. You will be given the equation, then you look at the equation and state or simplify simply a little more to determine or to state the gradient of any given equation of a straight line. We shall state. Then lastly, we are to apply the relationship of gradients. We are to apply the relationship of gradients of parallel and perpendicular lines to determine the equation of a straight line. To determine the equation of a straight line. Well, meanwhile, these are the 4 or 5 or compressed 4 learning outcomes that we should know by the end of our topic. Mainly, we are going to start with determining the gradient of a straight line given the points. Therefore, get a breath of like 3 to 5 seconds. We kick off with our first learning outcome, which is this one here. There is a reason why, because the moment you know this, all of these are going to be easy for you, and then the learning will be even simplified on my side to make you understand. Well, let's kick off with the first learning, with our third learning outcome, determining and stating the gradient of a straight line. But though we have to start with determining. All right, let's go. We are to determine the gradient. The gradient can be called the slope, or it can be called the steepness of a straight line. This is what you're going to be looking at. But mainly you may be asking yourself, what is a gradient? Or you may be asking yourself, the teacher, what could be the real life applications of the gradients? Mainly, I can tell you that a gradient is a ratio of a vertical rise. Let me say you have a road. A road is rise. Remember, we have horizontal roads, but we have those that are being backed at any given angle and are inclined, like hills. Those hills have what we call a gradient. But then when you're determining the gradient, we've said that a gradient is a ratio of a vertical rise to the horizontal movement. We can take this to be the definition of the gradient. And mainly in this, you may be asking yourself, teacher, where they applied in real life? In real life, we can take an example of civil engineering during the construction of the buildings. My friend or my student, when the inclining or when they are making the staircases to be raised at any given slope, I believe when you're hearing me using the word slope, the slope means something is not horizontal, but it is raised above the horizontal line. Like as in, this is the horizontal line, but when they're making the staircases, they might decide to use a given slope to raise these staircases. If at all, maybe they are going to a next floor like that. Then another thing where the slope or the gradient is being applied, it is in construction of roads. A road, let me say, it's to be constructed along a hill, and on that hill, a given road has to be constructed at a given angle, and mainly that angle is called the angle of banking.